Preparing for an AI Observability Engineer interview? You've reached Interview Guide, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question, you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What does AI observability mean, and how is it different from traditional application observability? AI observability extends normal observability into the model and data layer. I still care about latency, errors, saturation, and traces. But I also track prompt versions, retrieved context, token usage, output quality, hallucination signals, drift, and user feedback. Traditional services usually fail with clear exceptions. AI systems can return fluent but wrong answers. So the goal is not only uptime, it is trustworthy, measurable behavior across data, model, prompt, and infrastructure. While answering, focus on the expanded signal set: traces, logs, metrics, prompts, embeddings, model outputs, evaluations, drift, cost, and safety. Contrast deterministic software behavior with probabilistic AI behavior. Question 2. What key metrics would you monitor for a production LLM application? I would split metrics into 4 groups. Reliability includes request rate, error rate, timeout rate, streaming failures, and P95 or P99 latency. Cost includes input tokens, output tokens, cache hit rate, and spend per user or feature. Quality includes answer acceptance, groundedness, retrieval precision, and evaluation scores. Safety includes toxicity, policy violations, PII leakage, and jailbreak attempts. This balance prevents teams from optimizing latency while quietly damaging quality or cost. Make sure to cover reliability, quality, cost, and safety metrics. Include latency percentiles, error rates, token consumption, retrieval quality, hallucination rate, user feedback, fallback rate, and model provider availability. Question 3. How would you instrument an AI pipeline using OpenTelemetry? I would create a trace per user request and spans for each major AI operation: prompt rendering, embedding generation, vector search, re-ranking, LLM call, tool execution, and post-processing. Each span should include safe attributes like model name, prompt version, token counts, latency, status, and cache behavior. I avoid logging raw secrets or PII. OpenTelemetry is useful because it connects AI-specific signals with the rest of the service graph. In your answer, talk about distributed traces across API gateway, orchestration, model calls, vector database, tools, and evaluation steps. Mention span attributes, semantic conventions, sampling, and sensitive data redaction. Question 4. How do you detect hallucinations in an LLM-powered system? Hallucination detection needs multiple signals, not one magic metric. For RAG systems, I compare the answer against retrieved sources and check whether claims are supported by citations. I may use an evaluator model to score groundedness, but I calibrate it against human-labeled examples. I also track user corrections, low-confidence responses, and domain-specific rules. The key is treating hallucination as a risk score, then routing high-risk cases to fallback or review. Be sure to mention groundedness checks, reference attribution, retrieval overlap, evaluator models, user feedback, human review, golden datasets, and the limitation that hallucination detection is probabilistic, not perfectly deterministic. Question 5. What is model drift and how would you monitor it in production? Model drift means the production environment is moving away from the data or assumptions the model was trained or validated on. I monitor input feature distributions, embedding distributions, output class balance, confidence scores, and downstream business metrics. If labels arrive later, I use proxy signals first, then validate with ground truth. I prefer baseline comparisons by segment because global averages hide failures. Drift alerts should trigger investigation, not automatic retraining every time. While answering, cover data drift, concept drift, embedding drift, prediction distribution changes, label feedback delay, statistical tests, baseline windows, alert thresholds, and business impact validation. Question 6. How would you design observability for a RAG application? For RAG, I observe both retrieval and generation. During ingestion, I track document freshness, parsing failures, chunk counts, embedding errors, and index lag. At query time, I trace embedding generation, vector search, re-ranking, context assembly, and the final LLM call. Quality metrics include recall on test queries, citation accuracy, groundedness, and no answer correctness. The most important debugging feature is answer lineage. Which chunks were retrieved, used, ignored, and cited. Make sure to cover ingestion quality, chunking, embeddings, retrieval metrics, re-ranking, context utilization, answer groundedness, latency breakdowns, vector database health, and traceability from final answer to source documents. Question 7. What logs should an AI observability system capture, and what should it avoid logging? I prefer structured logs that capture request ID, user segment, prompt template version, model version, provider, latency, token counts, tool calls, retrieval IDs, evaluation scores, and failure reason. I avoid logging raw PII, secrets, credentials, and full proprietary documents unless there is a clear policy and encryption boundary. When content is needed for debugging, I use redaction, sampling, short retention, and access controls. Observability should reduce risk, not create a shadow data leak. In your answer, discuss structured logging, request identifiers, prompt metadata, model outputs, evaluation results, redaction, hashing, retention policies, compliance, and avoiding raw sensitive information unless explicitly protected. Question 8. How would you set SLOs for an AI product where quality is subjective? I would define separate SLOs for reliability, latency, cost, and quality. Reliability can use standard indicators like successful responses and P95 latency. Quality needs agreed proxies, groundedness score, task completion rate, human approval, thumbs up rate, or benchmark pass rate. I would set them per critical user journey, not only globally. Because subjective quality changes with product expectations, I would review thresholds regularly with product, support, and domain experts. Be sure to mention separating availability SLOs from quality SLOs, defining measurable proxies, using human-labeled sets, segment-level targets, error budgets, and periodic recalibration with product stakeholders. Question 9. How do you monitor and control LLM cost in production? I monitor cost at the same granularity as performance, per tenant, feature, model, prompt version, and request type. The core metrics are input tokens, output tokens, cache hit rate, retries, tool calls, and provider charges. To control cost, I use prompt trimming, response length limits, semantic caching, smaller models for easy tasks, and alerts on spend anomalies. The trick is not just cutting tokens, it is preserving quality where users notice. While answering, include token accounting, per feature cost attribution, prompt optimization, caching, model routing, rate limits, anomaly detection, budget alerts, batching, and the trade-off between cost and answer quality. Question 10. What is prompt observability, and why does prompt versioning matter? Prompt observability means tracking how prompt changes affect behavior. I record template version, rendered variables, model configuration, retrieval context, and evaluation outcomes. Versioning matters because a small wording change can shift accuracy, tone, safety, token usage, or latency. Without versions, incidents become impossible to reproduce. I treat prompts like production code, reviewed, tested on golden sets, released gradually, monitored after deployment, and rolled back when regressions appear. Make sure to cover prompt templates, variables, experiment tracking, output regression, rollback, reproducibility, approval workflows, and linking prompt versions to latency, cost, quality, and safety metrics. Question 11. How would you evaluate the quality of an AI observability alert? A good alert is actionable, specific, and tied to user impact. I evaluate whether it catches real incidents, avoids noisy false positives, identifies an owner, and links to a runbook or dashboard. For AI systems, I do not alert on every metric wiggle. I correlate quality, latency, cost, and safety signals. For example, retrieval latency rising may matter only if answer success drops. Alert fatigue is an observability failure. In your answer, talk about precision, recall, noise, actionability, severity, ownership, runbooks, correlation across signals, alert fatigue, and whether the alert maps to user impact or business risk. Question 12. How would you debug a sudden drop in answer quality after a deployment? I would first compare the bad window against the previous healthy baseline. Then I would segment by model version, prompt version, customer, language, traffic source, and query type. I would inspect traces for retrieval failures, missing context, longer prompts, tool errors, or provider changes. Next, I would run the new version against golden test cases. If customer impact is high, I roll back first and continue root cause analysis after stabilizing. Be sure to mention comparing deployment versions, prompt changes, model provider changes, retrieval changes, data ingestion, traffic mix, evaluation dashboards, traces, rollbacks, and isolating regressions by segment. Question 13. What role do embeddings play in AI observability? Embeddings help observability systems understand semantic behavior, not just exact strings. I can cluster user queries, detect emerging topics, find outliers, compare production traffic against training or evaluation data, and inspect retrieval failures. In RAG, embeddings reveal whether poor answers come from query mismatch, bad chunks, or index quality. I always track the embedding model version because changing it can silently alter similarity scores and retrieval behavior. While answering, explain embeddings for semantic similarity, clustering, anomaly detection, drift monitoring, duplicate detection, query analysis, retrieval debugging, visualization, and the need to track embedding model versions. Question 14. How would you monitor an AI agent that uses tools and multi-step reasoning? For agents, I need observability at every step, not just the final answer. I trace the plan, tool selection, tool arguments, tool results, retries, memory reads, and stopping condition. I track loop count, accumulated tokens, total cost, tool failure rate, and whether the final task succeeded. Safety checks should inspect tool permissions and sensitive actions. Agents fail through bad reasoning, bad tools, or uncontrolled loops, so the trace must expose that chain. Make sure to cover step-level tracing, tool call inputs and outputs, loop detection, budget limits, intermediate decisions, failure classification, safety checks, latency cost accumulation, and final outcome evaluation. Question 15. How do you balance privacy with the need to inspect prompts and model outputs? I start with data minimization. Collect metadata by default, and content only when justified. For prompt and output inspection, I apply PII detection, redaction, encryption, strict access controls, and audit logging. I also use sampling and short retention windows. In regulated environments, customers may need opt-outs or tenant-specific storage. The best design gives engineers enough signal to debug, while ensuring sensitive content is never casually searchable. In your answer, include data minimization, PII detection, redaction, encryption, role-based access, audit logs, sampling, retention windows, customer controls, and secure debugging workflows. Question 16. What dashboards would you build for executives, product teams, and engineers? I would build different views for different decisions. Executives need adoption, cost trend, incident count, safety risk, and quality trend. Product teams need task success, user feedback, feature-level usage, deflection rate, and segment performance. Engineers need request rate, latency percentiles, provider errors, token usage, trace drill downs, retrieval quality, prompt versions, and recent deploy comparisons. A single mega dashboard usually fails because it mixes strategy, product learning, and incident response. Be sure to distinguish audience needs. Executives need business and risk trends. Product needs adoption and quality. Engineers need traces, latency, errors, cost breakdowns, retrieval metrics, and deployment comparisons. Question 17. How would you test observability before launching an AI feature? Before launch, I test the feature and the observability around it. I run golden datasets, synthetic traffic, red team prompts, and load tests, while verifying that traces, metrics, logs, and evaluations appear correctly. I simulate provider timeouts, vector database failures, bad retrieval, and safety violations to confirm alerts and fallbacks work. I also check dashboards with product and on-call engineers. If we cannot observe failure modes, we are not ready to launch. While answering, cover pre-production evaluation, synthetic traffic, golden datasets, chaos testing provider failures, red team prompts, data quality checks, dashboard validation, alert dry runs, and rollback readiness. Question 18. How do you handle observability when using third-party model providers? With third-party providers, I treat the model call as an external dependency with quality implications. I monitor latency, timeout rate, error codes, rate limit events, token usage, model identifiers, and regional availability. I also keep my own quality evaluations because provider dashboards rarely know my business task. For resilience, I design fallbacks, retries with backoff, model routing, and budget limits. Vendor abstraction is useful, but it should not hide critical telemetry. Make sure to discuss provider latency, error codes, rate limits, token accounting, model version changes, regional availability, fallback routing, contract limits, vendor dashboards, and independent quality monitoring. Question 19. How would you investigate a spike in unsafe or policy-violating AI outputs? I would first contain the issue by tightening safety filters, disabling risky flows, or rolling back the last change. Then I would segment the spike by prompt version, model, user cohort, language, and input pattern. I would inspect traces for jailbreak attempts, unsafe retrieved context, tool misuse, or moderation bypasses. After root cause, I would update tests, classifiers, prompts, and runbooks. Safety incidents need both technical fixes and clear auditability. In your answer, talk about safety classifiers, prompt and model version comparison, input attack patterns, jailbreak detection, retrieval contamination, moderation logs, incident severity, containment, and post-incident remediation. Question 20. How would you design an end-to-end AI observability platform for a company? I would design it as a layered platform. Applications emit standardized AI telemetry through an SDK, traces, prompt metadata, model calls, retrieval events, evaluations, and feedback. A streaming pipeline validates, redacts, and routes data into trace storage, metric storage, a prompt registry, and an evaluation store. Dashboards and alerts sit on top with team ownership. The platform must scale cheaply, enforce privacy, and make AI behavior reproducible across deployments. Be sure to cover architecture, instrumentation SDK, event pipeline, storage, metrics, traces, prompt and evaluation store, privacy controls, dashboards, alerting, integrations, scalability, and governance across teams. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.